Okay, this is a video associated with Unit 5, Activity 2, the Pythagorean Theorem. I think you probably learned the Pythagorean Theorem in grade 7 or 8, but so we're just going to go over how to apply it. There's some interesting problems, and it's kind of a quick review. So the Pythagorean Theorem is that a squared plus b squared equals c squared. And we're going to use that to find the missing side in a right-angled triangle. The first thing to notice is that every time we use the Pythagorean Theorem, we have to be sure that we have a right angle in our triangle. If we don't, the Pythagorean Theorem won't be sufficient, and we would need to use what's called trigonometry to find the missing sides. And you'll cover that in your grade 10 math class. But in this course, we can only find the missing side in a triangle if it's a right angle triangle, where A and B are the two legs. So the legs are the two short sides, those are interchangeable. And the hypotenuse, which is C, is the longest side, which is always directly across from the right angle. So the first thing I always recommend that students do is label your three sides A, B, and C. So anytime you're doing a Pythagorean theorem problem, I would make a diagram and then label your sides A, B, and C. A and B are interchangeable. It doesn't matter. I could also do 6 is A and 8 is B, but your longest side always has to be C. After that, we're really just plugging numbers into a formula and then solving algebraically, which we're pretty good at this point in the course. So I know that A is equal to 8, and I know that B is equal to 6. I think it's a good habit to always substitute things in with brackets. And then I don't know C, but which we're calling X, right? We often use X to mean something we don't know. So now I've got an equation, and I only need to solve it for X. So we know 8 squared is 64. I know 6 squared is 36. And I sum those together. 64 plus 36 is 100. So 100 equals X squared. So I'm not done the problem. It doesn't mean that side lengths X is 100, X squared is 100. So we know when we're doing algebra, if I want to undo or move them to the other side, I need to do the opposite. Well, the opposite of squaring something is going to be taking its square root. So I'm going to take the square root of both sides here. And the square root and the squares are going to cancel out. That's going to leave me just X. So the opposite of square root is squaring, just as the opposite of multiply is divide, or the opposite of add is subtract. So I'm left with X equals square root 100, and we know that the square root of 100 is 10. We won't always get an integer number, so you should be comfortable finding that on the square root, but on your calculator as well. So X equals 10 centimeters. Again, every question in this unit, we're going to need units because we're doing measurement. Let's do the same thing. Let's do one more example. Again, take your time and be careful labeling the sides. So I've got A and B are my short sides, my legs. My longest side across from the right angle is the hypotenuse. So again, I'm going to start with A squared plus B squared is C squared. And we can see right away it's a slightly different type of problem, because this time I need to find out one of the legs. I don't know side B, which I'm calling X, but I do know the hypotenuse, which is 17. So 8 squared is 64. I don't know what X is yet. And then 17 squared is 289. Again, you could use your calculator. It's helpful to know some of these kind of smaller numbers, what their squares are. So again, I want to solve this algebraically. I want to get X by itself. So the positive 64 comes onto the other side. So X squared is going to equal 289 minus 64. So X squared equals 225. But I just want X, so I need to do the opposite of squaring to the other side. So I take the square root of 225, which I know is 15. So my missing side is 15 centimeters. And we just want to do a quick check. We always want to see, like, is our answer reasonable? We were trying to find out one of the legs, so it definitely should be shorter than the hypotenuse, so 15 centimeters makes sense. My diagrams won't always be to scale, but we know that if we're finding the hypotenuse, that's got to be the longest of the three sides. And if we're finding one of the legs, it's got to be shorter than the hypotenuse. So that's how we apply the Pythagorean theorem to find a missing side of a right angle triangle. It works for either finding the hypotenuse or one of the legs. You might notice in this problem that we've had an integer or a whole number answer. This won't, of course, always be the case. I could get a decimal when I square or square root. It is interesting to know or to note what we call our Pythagorean triples. So 3, 4, 5 is the smallest whole number Pythagorean triple, because 3 squared is 9 plus 4 squared is 16 equals 25. Maybe I'll write that in red beneath it. So that's one example I have 9 plus 16 equals 25. So it's called what we call a Pythagorean triple. These could be the sides of a right angle triangle. This one has another example. So 8, 15, 17 is a Pythagorean triple because 64 plus 225, when I square them, equals the square of the third. So there are a bunch of Pythagorean triples with all three numbers under 100. It might help to try to find those or recognize those or learn those. I'll give you just one more. 5, 12, 13. Is that a Pythagorean triple? You can check. And then can you think or look for more Pythagorean triples that have small integer side lengths? And if you can recognize those, sometimes that will make a lot of problems in grade 9 and 10 math a little bit quicker. So that's a quick introduction to the Pythagorean theorem. And as always, please send me an email if you got any questions. Okay, thanks for watching.